For instance, if we take the first two elements, we can pour water inside it up to this level. If we pour more water, it will overflow from the left side. If we take these two heights, it can hold water up to this level. If we pour more water, it will spill over from the right side. Hi everyone, this is part 2 of the Leetcode problem 11, container with most water. In the first part of this video, we had discussed how to solve this problem using the brute force approach. We had also learned the limitations of using the brute force approach. In this video, we will see how we can solve this problem more efficiently. If you have not yet watched part 1, I suggest you to watch that first and then come back to this video. It will help you with understanding this problem more easily. I have provided the link to part 1 in the description below. Okay, without much delay, let's begin today's video. In this solution, we will be making use of the two-pointer technique. If you have watched our previous solution, you would know what we are basically asked to do here is to find the maximum area of the square or rectangle from the given array. Now, ask yourself, what is that we have to do in order to maximize the area? It basically boils down to these 3 points. We would ideally want the left and right heights to be a large value, or the distance between the left and right heights should be large, or it should be a combination of both. These are the 3 factors that contribute to maximizing the area. The two-pointer technique leverages exactly these 3 points in order to find the result. In this algorithm, we make use of 2 pointers, left pointer and right pointer. We start with the left pointer pointing to the first element in the array and right pointer pointing to the last element in the array. The reason for starting the algorithm from the two extreme ends is the second factor that we discussed earlier, to maximize the distance between the two heights. More the distance, higher is the chance of getting a bigger area. We then calculate the area formed using the current left and right heights, and then in each iteration we move either the left or right pointer inwards based on certain conditions. We will see what those conditions are as we move further in this video. Let's understand how this works by taking this array as an example. Let's take a variable called max area to store the maximum area that we have encountered so far, and a variable current area to store the current area. As mentioned earlier, left pointer starts from the first element and right pointer starts from the last element in the array. For each iteration, we calculate the area that we can form using the current left and right heights. The area that we can form using these two heights is 8 units. So we update our current area to 8 units. This current area is greater than the max area that we have so far. So we update max area to 8 units. Now we need to move either the left or right pointer inwards. How do we decide which one we should move? Remember the first factor that we discussed earlier. Larger the height, higher is the possibility to maximize the area. Therefore, if we consider our current heights, there is no point in keeping the lower height 1 as compared to height 8. That is why we discard the lower height 1 by moving the left pointer inwards and retain right height 7. Next we compare heights 8 and 7. The area that we get by using these heights is 49. So let's update current area to 49. This is again greater than the max area. So we update max area to 49. Now 7 is smaller of the two heights. So we discard height 7 by moving our right pointer inwards. Next we compare heights 8 and 3. Now current area is equal to 18, which is less than our max area, so we don't have to update the max area. Since height 3 is lesser than 8, we discard 3 and move our right pointer inwards again. Now current area is equal to 40 units, which is better than the previous current area that we got, but is still less than our max area, so we don't update max area. At this point, both left and right heights are equal. So which of the left or right pointers do we move inwards now? If you take a moment and think through this, you would realize it doesn't really matter which pointer we move inwards. When the heights are equal, we can either move left or right pointer. It doesn't really make a difference. In both cases, we will end up getting exactly the same result. You can take this as an exercise and verify it for yourself by comparing both the possibilities. For now, let's move the left pointer inwards and continue our algorithm. Next, current area is equal to 24 units, which is again less than the max area, so no need to update max area. and left pointer height is less than the right pointer height, so we move the left pointer inwards. Let's repeat the same process again. Current area is equal to 6 units. Again, no need to update the max area. We move the left pointer inwards again. Once again, current area is less than our max area, and we move the left pointer, and same again with this combination as well. At this point, both our left and right pointers meet. This is where we need to stop the algorithm and return whatever is in the max area variable as the result. So far, if you found this video useful, quickly like the video and show us your support. Each of your likes means a lot to us. It also helps such videos reach out to more people. I will be coding this in Go language. You can easily code this in any other programming language you like by following a similar approach. If you still want the exact solution in other programming languages, you can visit our website code-recipe.com. Okay, let's code this now. Yeah, first I will create a variable called max area to store our result. Let me also initialize our left and right pointers. I will name the left and right pointers L and R respectively. Okay, let me initialize the left pointer to point to the first element in the array and initialize right pointer to point to the last element in the array. Let's now write the loop to iterate through the height array. This loop has to run till our left and right pointers meet. Once they meet, we will have to terminate this loop. Let me write that condition. Next, let's calculate the current area value for the current iteration. Once we have our current area, if this value is greater than max area value, we will be updating the max area value. Let me code this as well. And then finally, let's write the condition to increment or decrement the left and right pointers. If left height is less than the right height, we increment the left pointer. Otherwise, we decrement the right pointer. And the last step is to return the max area as the result. That's all. Let's run this. As you can see, this algorithm is pretty fast and runs without any errors. In this algorithm, since we iterate through the array only once to find the result, it has a linear time complexity. Therefore, if n is the size of the given input array, the time complexity of this algorithm is O of n. The space complexity of this algorithm is O of 1, as we are not using any extra space. That is all for today's video. Please like the video if you have not done it yet. If you have any questions, you can ask me in the comments below. I'll be happy to answer you. This is Code Recipe signing off. I'll see you in the next one. Until then, happy learning. Bye bye.